Okay, I just want to interject really quickly what it means for the area under the graph to be negative. So in the example just now I drew, right, I drew y equals to x, and I told you that the area under the graph is given by the integral of x dx. So the area under a graph from x equals to a to x equals to b is equals to the integral of the function, in this case is x dx, from a to b, right? And we saw that this one is equals to half b squared minus half a squared. Now, just now I plugged in some positive value for a and b, but what if I plugged in a negative value for a? So if I plug in a negative value for a, there is an interpretation, which is that if I plug a negative value for a, because this is x equals to 0, right? So if x is a negative number, let's say x is minus 2, and I integrate to, let's say, x equals to 3, right? Then if I perform this integral, if I substitute in b equals to 3 and a is minus 2, you see that the answer in this case will be half 3 squared minus half negative 2 squared, which is equals to 4. But this area it looks quite big. How compared to just now we had x equals to 2 to x equals to 3, we said that the area from x equals to 2 to x equals to 3 was 4, right? But now I'm saying that the area under the graph from minus 2 to 3 is 4 also. So that might seem a little bit counterintuitive, but the answer is simply that the area here is negative, right? Whereas the area here is positive. So the area under the graph is picky about the sign. If your area under the graph, if your function is above the x-axis, then the area is defined to be positive. Whereas if your function is below the x-axis, then it's a negative area. Okay, so that's just a note about negative areas, and we'll actually see we'll see it appear in kinematics, and this is just something that we have to take note of. And now you have a question: what if I do want to find the like the area geometrically, right? I do not want this area to be negative. Then the answer is that for your function, if your function has both negative and positive areas on the graph, if your function is both below and above the x-axis, let's say your function looks something like that, right? Then if you want to find, because this is positive area, this negative area, this negative area, and this positive area, right? If you want to find these regions as positive areas, then you need to find the x coordinates of the zeros of the function, right? And then you need to perform this integral separately. And you perform this integral separately. And then when you get a negative sign, you reverse it. But yeah, so that's what you need to do if you want to find a geometric area. But in general, we won't really be doing a lot of that in physics. Yeah, unless you want to find the distance traveled by a particle, which some questions do ask, but we'll come across it when we come across it.